Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 2.4, which is going to deal with investigating symmetry. Now, just to let you know, section 2.4 is the end of module 2, and since it is our last section for the module, that means that you will have a quiz upcoming. So something to be aware of and something to look out for in the days ahead. So, with that said, let's go ahead and get into our lesson today for symmetry. Today we have one learning goal, and our learning goal for today is you will be able to determine if a figure has a line of symmetry or rotational symmetry. So we're going to look at these two different types of symmetry. We're going to determine if it has a line of symmetry or rotational symmetry, and then see what that looks like for today. All right. Let's get started. All right, so a figure has symmetry if a rigid motion exists that maps the figure back onto itself. A figure has a line of symmetry if a reflection maps the figure onto itself using that line, if we reflect over that line, that is. Each of these lines of reflection is called a line of symmetry. So if we look at the figure they give us here, it looks like a moon. Okay, a line of symmetry for this shape would go down the middle, left to right. Okay, so if I were to cut out this shape and over this line, if I were to reflect over this line or fold my shape over that line, it would map back onto itself. Meaning, if I fold this top part over this line onto this bottom part, it should match up perfectly onto itself. Or if I reflected over this line, it would line up back onto, or map back onto itself perfectly. So a line of symmetry is just going to be a line that I can cut the shape in half, where one half would be the same on the other side, but just reflected. And if I did, okay, an idea that I could cut this out, fold it over that line, and it would match up perfectly. So that is a line of symmetry. Some shapes have more than one line of symmetry. For example, a square has 4 lines of symmetry, and I'll show you an example similar to that so you can see what I am talking about. So if a shape has a line of symmetry, it's where you can cut the shape in half and you could fold it back onto itself. Some shapes do not have any lines of symmetry, and we'll take a look at those as well. All right, rotational symmetry, and that's going to be this whole part right here. A figure has rotational symmetry if a rotation maps the figure onto itself. The angle of rotational symmetry, which is greater than 0, but less than or equal to 180, is the smallest angle of rotation that maps the figure onto itself. So, rotational symmetry means that I can rotate this to the left or to the right, but I could rotate this counterclockwise a certain amount and it would map back onto itself. So with my 5-point star here, my angle of rotational symmetry is 72 degrees. That means if I rotate it 72 degrees counterclockwise, okay, this point would end up here, and all the points and all the sides would match up perfectly. So rotational symmetry means that I can rotate that shape and it matches back up or it maps back onto itself. Now the angle of rotational symmetry has to be greater than 0, but it has to be less than or equal to 180. Okay, our rotational symmetry can be 180, but anything over 180 for your order or your starting point does not work. Now, let's say I go through and rotate my shape, and it has one angle of rotation, and it's 360. We're not going to consider the fact that I can rotate a shape all the way back around to get back to its starting point as an angle of rotation. Okay, 360 is a given the fact that it goes back to its starting point. Now, an angle of rotational symmetry is a fractional part of 360 degrees. Notice that every time the 5-pointed star rotates 360 over 5, or 72 degrees, the star coincides with itself. Now, there's a couple ways we can do this to figure out the 72 degrees. Okay, we did 360 divided by 5, Well, if we look at our shape, okay, we have 5 angles and parts that are the same. So because I know those are the same measure, the side lengths are the same measure, and it's all congruent, knowing that, I can take this 360 and divide it by 5 because there's 5 parts. Now, I'm going to go through and show you another way to do it using, I'm going to use parchment paper, but you can use wax paper or paper to do this as well. And I'm going to show you how we can do that using parchment paper today. Now, once we know the starting point, okay, 72 degrees. Okay, 72 degrees is our start, and every angle of rotation, adding 72 going up to 360 is considered an angle of rotation for this shape. So 72, 144, 216, and 280 are other angles of rotation for this star. All right, so with that said, example 1 for today is the whole set of notes, and it's really just parts A through J. So there's a lot of different parts to example 1. It's really just going through and practicing different situations of symmetry. So that's what we're going to take a look at today. Example 1 is going to ask us to describe the symmetry of each figure. So we're going to determine if it has a line of symmetry. If so, we're going to draw those lines, and then to name the angles of rotation if it has angles of rotation. Now, on paper, I'm going to start with the angles of rotation, just because when I start drawing the lines, it can make it a little more confusing for what I am talking about. All right, so like I said, I'm going to use parchment paper to do this, like I did with reflections and some proofs with rotations. Okay, again, you can use parchment paper is what I'm using, I recommend. You can use wax paper. It's just a little harder to trace your shape because wax paper is a little more waxy. Or you can use paper by being a little more careful. Again, I don't recommend you put this up to your computer screen and trace on your screen. Okay, I suggest you put it on paper, just draw a sketch of it, and then go through and practice. Now, if you don't have parchment or wax paper around, okay, I will show you a way to identify what our order of rotation is. So using my parchment paper, I'm going to go through and trace my shape. Doesn't matter how hard you press, like we have done before for reflections. Okay, I just need to trace it. So I'm going to trace my shape, and it looks like that. So if I look at my original image and my tracing, okay, they match up, and that is what I'm looking for. Now, before we go through and start trying to identify the rotational symmetry, something I always suggest is you put an indicator about where you're starting your rotation or the top part of your figure. So I'm going to put a little dot at the top. The reason I do that because once I start rotating this paper, it's helpful to know on my parchment paper where I started rotating. So I know that this dot, once I finish rotating, needs to end up back at the top. And that's why I put the dot there. So if we go through and do this, what we're going to do is just start rotating counterclockwise with our traced shape, and we want to see how many times as I rotate 360 degrees it matches back up with itself. So if I go ahead and start, we're just going to rotate counterclockwise, and here I get it to match up right there. So that is one time that it matches back up on itself. Let's continue until we get all the way around to see how many times it will line up. So there's 1, there's 2, and 3, And then lastly, coming back around, we go back to our starting point. Okay, our starting and ending point, we are going to count as one of them as well. So that means I'm at 4. So my order of rotation, okay, so my order is the number of times it maps back onto itself. So in this case, it would be 4, because it mapped back onto itself 4 times. And using that 4 to figure out our rotational symmetry, we're going to take 360 and divide by 4. So if we do 360 divide by 4, we are going to end up with 90 degrees as our angle of rotational symmetry. Now, some problems just want to know the smallest angle of rotational symmetry, which in this case would be 90, so then you would be good to go and you're done. Some problems want to know all the angles of rotational symmetry. So to do that, we're going to take our 90, we're going to start with that, and we're going to add in 90 degree increments. So we're going to do 90 plus 90, so 180, and we're going to keep doing that until we get to 360. So we'll add 90 again, we get 270. And then if I add 90 one more time, we get 360. Now, we're not going to be worried about 360, so I'm not going to include it in my set. And then these are the angles of rotational symmetry. If it only gives you one, say like it tells you 90 degrees as one of the options, that does work. You don't have to list it all the time. Just know that some problems do list all the angles of rotation for our shape. And that's how you figure out the other ones, is you just keep adding in increments of 90 or whatever your rotational angle of rotation is until you get to 360. All right, the next part is going to be lines of symmetry. So lines of symmetry would be going through and drawing lines through our figure to figure out where we can cut the shape in half to then fold it back onto itself. A couple things and a couple ways you can do this. First of all, is you can take your parchment paper or wax paper and you can go through and just fold the shape and try to get it to match back up with itself where it lines up perfectly like that. So that would be a line of symmetry. Or you can kind of just go through and try to identify by looking at it where those lines of symmetry would be. So don't feel like you have to go through and draw a shape and then fold the paper. It's just an option of how to do it. Now, to save time, I'm not going to go through and fold parchment paper a whole bunch of times. I'm just going to go through and draw our lines of symmetry and identify how many we have. So, if we start here, I'm going to start by drawing my first line of symmetry going from top to bottom right through the middle. So we're going to take our ruler, where I am, and I'm going to draw my first line of symmetry right through the middle, meaning if I were to reflect over this line, okay, this shape would match up. Much like if I just went and reflected over this line, it would match up with itself like that. So that is what a line of symmetry is stating. Another way is that it would fold onto itself, just like if we were to take the parchment paper. Okay, if I fold over that line, it's going to line up with the other half. And that's what we are going to be doing for this. All right, so that is one line of symmetry. Another one is that I can go through the middle, left to right. So that's my second line of symmetry. I can cut through diagonally for this one. And then I can also go through the other way diagonally. And that is my other line of symmetry. So I have one that goes top to bottom, two that goes left to right, three that goes diagonally, and 4 is another diagonal. So that means I have 4 lines of symmetry. So my order of rotational symmetry is 4. And I do 360 divided by 4 to find my angle of rotation and keep adding. My lines of symmetry is how many times I can cut the shape so that it would map back onto itself. Now, something to note, this has 4 different times it maps back onto itself, and this has 4 lines. That is not always the case. Okay, the 4s don't always match up for this. All right, so with that said, let's kind of continue on with a few more examples. Now for part B here, we have a 3-pointed star. What you would do for this is, again, you're going to go through and trace your shape using parchment paper or wax paper. You go through and trace it and then see how many times rotating that trace shape it maps back onto itself. And I'll show you how we do that here in a second. Before I do that, just what I want to say real quick, just by looking at this, okay, and this is just to kind of give you practice in case you don't have parchment or wax paper available. If we look at this shape, about how many times do you think it would map back onto itself? In my mind, because we have a 3-point star and all 3 angles are the same measure here, and these side lengths are the same measures indicated by the tick marks, because I know that all those parts are equal, it's a 3-pointed star, so my guess is going to be that this is going to map back onto itself 3 times. So the order here was 4. I'm going to make my guess that the order for this one is going to be 3. Now I'm going to go through and prove that to be true for this one, just to kind of demonstrate it, but I just want to show you how you can do this maybe a bit quicker, not having to use parchment or wax paper. Now I have already gone through and traced my shape. You are going to see a few other shapes on here. They're for future examples. Just kind of saves me time from going through and tracing it a bunch of times. So if I cover up. So I have gone through and traced my shape, my 3-pointed star. As I start to rotate my shape, okay, I get it to map back onto itself once, twice, and then eventually I get back to my starting point and I end up with my order of 3, meaning it maps back onto itself 3 times, which is what I had guessed from the start. So you can do this without necessarily needing tracing paper for these problems. It's just a way that you can do it if you are struggling to see it. So knowing my order is 3, we're going to take 360 and divide by 3. And when I do 360 divide by 3, we get 120 degrees for my angle of rotation. Now, like I said, to figure out your other ones is you keep adding that number until you get to 360. So my next number would be 240 degrees, and then after that it's 360. So those are my angles of rotation. Now, for lines of symmetry for this one, okay, I can do one going through each point through the other side. So I can draw one going from top to bottom. I can draw a diagonal going through the right point. I didn't fully match that up, but it works. And a diagonal going from the left point through the other side. Now, I know I kind of got a little off there, but you should get the idea. So I have 1, 2, 3 lines of symmetry. And that is my answer for that. All right, so that is going to be how you go through and do these problems for today. For rotational symmetry, either look at the angles and see how many match up to figure out your order. Then you do 360 divide by that number to figure out your rotation. Lines of symmetry is going to be kind of visual or cutting out a shape or putting it on tracing paper and then folding to see when it matches back up on itself. The rest of the examples are just going through and showing you that. So instead of doing each one step by step and drawing this out, I am going to put my completed notes up here in a second, walk through and explain different ones, why it has that many lines, why it has no lines, how you do the angles of rotation, or why it has no angles of rotation. You can always take a look at my completed notes if you feel comfortable with this right now for reference while you are doing homework. But with that said, let's go ahead and jump into the other parts. So I'm going to put my completed notes, and I'm just going to walk through how I came up with each part. So the first one for C, so we have a square. I have 4 angles that are the same measure. So my order would be 4. So I'm going to do 360 divided by 4. And I end up with 90, 180, 270. Now, it's not just because I have 4 congruent angles, but because all 4 of the vertices are congruent. Okay, just like over here, while I have 2 angles are congruent, not all the vertices have a matching part. So that's why there's no angles of rotation for part D. Now, lines of symmetry for a square is I can go through diagonally or top to bottom, left to right, and I can also cut through diagonally. Whether you have a square on its point like that, or whether you have it set up like this, I can go top to bottom, left to right, diagonally, diagonally. So a square, or in this case a rhombus or diamond, has 4 lines of symmetry. All right, our trapezoid over here. Yes, I have 2 different angles that are congruent, but not all the vertices have a matching part. Therefore, there are no angles of rotation. And this has no lines of symmetry because there's no way I can cut this shape in half where it would match up with the other half. So no lines of symmetry and no angles of rotation for D. All right, on the back, I think some of these are kind of self-explanatory by seeing them and seeing what's done. E, our arrow has 1 line of symmetry moving through the middle left to right. I can't cut it up or down or diagonally. And there's no way that I can rotate this except rotating all the way back to its start to get it to map back onto itself. So 1 line of symmetry, no angles of rotation. For F, there are no lines of symmetry because there's no way that I can cut this shape in half to get it to fold back on the other half. But when I go through and rotate it, and this would be going through and using your tracing paper or parchment, whatever, if I go through and rotate this shape, okay, when I get halfway through, I do get it to match back up on itself. So my order in this case is 2. So we do 360 divided by 2, and we end up with 180. All right, G and H. G is going to be very similar to E, the arrow problem. I can cut it in half, but this time top to bottom. And there are no angles of rotation. There's no way I can map it back onto itself. H is our 5-point star, so we know the angles of rotation from our example on the front. And then I can go through draw lines of symmetry going from its point through the other side for all 5 points. And I can then fold that shape onto itself by doing that. All right, I is going to be very similar to F with this squiggle here. It's just a little bit more of a firm shape. So no lines of symmetry, but it does map back onto itself at 180 degrees. J is very similar to our square, just the angles are a little bit different. It has 4 lines of symmetry going top to bottom, left to right, and then the diagonals. And then my order of rotation is 4. So I do 360 divided by 4 and get 90, 180, and 270. All right, so that is our lesson for section 2.4 on symmetry. Again, parchment, wax paper, or even using paper is helpful, even tracing paper if you have it. If you don't have it, don't feel bad. A lot of these problems you can kind of do by looking at once you've seen a few examples done. Definitely suggest you either come back to the video or you take a look at my completed notes to give you some guidance on these problems. A lot of it is visual, and seeing it done a couple times or practicing a couple times does make this go a lot easier. All right, so with that said, that is our lesson for investigating symmetry on section 2.4. And that is all that I have for you guys today. Reminder that 2.4 is the end of Module 2, and to be expecting a quiz upcoming. So with that said, that is all that I have for you guys today. Thank you for listening. If you have any questions, just let me know next time you see me or shoot me an email, and I'll be more than happy to help any way I can. So that is it for today. Thank you for listening, and have a great day. All right, bye.